And now in this lecture we will find out the radius of the circle. In the drawing we have a big semicircle. Inside this big semicircle we have two smaller semicircles and one circle. It is given us the equation that this line segment equals to 140 units and this line segment equals to 70 units in its length. Our mission is to find out the radius of this small circle. Okay, so first of all we will define the relevant points for the question with names. This point will be A. The center of the semicircle will be defined as B. The touching point between the two semicircles will be defined as point C. The center of the biggest semicircle here will be defined as O. The center of the smallest semicircle will be defined here, it will be defined as T. And the touching point of the biggest semicircle with the smallest semicircle will be defined as E. We define the center of this circle as F. We define the touching point of the smallest semicircle with this circle as G. We define the touching point of this circle with this semicircle as H. And finally we define the touching point of the biggest semicircle with this circle as I. In addition, we define the radius of the biggest semicircle as capital R and the radius of this small circle as small r. That is the radius that we are looking for. So I write it down. Capital R is the radius of the biggest semicircle. And small r is the radius of the circle, that is the radius that we are looking for. Actually, it is given us in the question that this line segment AE is equal to 140 plus 70 units in its length. So we can write down that AE line segment AE, according to what is given us in the question, it is equal to 140 plus 70 units. 140 plus 70 is 210. We found out that the length of line segment AE is equal to 210 units. So AE equals to 210. But what is actually line segment AE? What is the definition of line segment AE? According from the drawing, it is very easy to see that line segment AE, it is the diameter of the biggest semicircle. And the diameter of any circle or semicircle is twice as long as the radius. And because of the fact that the radius of the biggest semicircle is equal to capital R according to our definition, therefore the diameter AE must be equal twice of it. So here we can write down that the diameter AE equals to the diameter of the biggest semicircle, and the diameter must be twice as long as the radius. If the radius of the biggest semicircle is capital R, then the diameter must be equal to 2 times capital R. Okay, so from this long equation, 2R equals to the diameter of the biggest semicircle equals to A equals to 210, we will derive that 2R equals to 210. 2 times capital R equals to 210 units. We will divide this equation by 2, and we get that capital R, the radius of the biggest semicircle, equals to 210 over 2 is 105 units. So we found out that the radius of the biggest semicircle equals to 105 units in its length. Point O is the center of the biggest semicircle. Point E is the point of the semicircle, of the biggest semicircle itself. This is exactly the definition of a radius. That is to say, OE is the radius of the biggest semicircle, and we just right now found out that OE equals to 105 units. Likewise, point O is the center of the biggest semicircle. Point A is a point on the biggest semicircle itself. Therefore, OA is the radius of the biggest semicircle that is equal to 105 units. Okay, and it is given us the question that this line segment AC is equal to 140 units in its length. But what is AC? Although it is very easy to see that AC is the diameter of this semicircle. And if the diameter of this semicircle was to 140, therefore the radius must be equal to half of it. That is to say, the radius of this semicircle AB equals to 140 over 2, that is 70. AB equals to 70 units in its length. Likewise, the radius BC of this semicircle equals also to 70 units. Likewise, it is given us the question that this line segment CE equals to 70 units. But what is line segment CE? From the way it is very easy to see that line segment CE, it is the diameter of this semicircle. And if the diameter of this the smallest semicircle equals to 70 units, it means that the radius CD must be equal to 70 over 2, that is 35. CD equals to the radius of the smallest semicircle equals to 70 over 2, that is 35 units. Likewise, the radius DE must be also equal to 35 units in its length. Okay. In the next step, we will find out the length of this line segment OB. From knowing that it is very easy to see that OB equals to OA minus BA. Again, OA minus BA equals to OB. So I will write it down. OB equals to OB equals to OA minus BA. So OB, the length of line segment OB is equal to OA. OA is the radius of the biggest semicircle, that is equal to 105, so we substitute OA by 105. Minus BA. We just right now found out that BA is the radius of this semicircle, that is equal to 70 units. So we substitute BA by 70. In conclusion, we found out that OB equals to 105 minus 70, that is actually 35 units. the length of line segment OB is 35 units. We write down in the drawing that OB equals to 35 units in its length. What is the length of this line segment OC? From the drawing it is very easy to see that OC equals to OE minus CE. Again, OE minus CE equals to OC. OE minus CE. Repeat again, the length of line segment OC is OE minus CE. So OC equals to OE is the radius of the biggest semicircle, that is equal to 105. So we substitute OE by 105 minus CE. CE is the diameter of the smallest semicircle, that is equal to 35 plus 35, that is to say it is 70 units. So substitute CE by 70. In conclusion, we found out that OC equals to 105 minus 70 is 35 units. So OC is also equals to 35 units in its length. So we write down that OC equals to 35 units in its length. OC equals to 35 units in its length. In the next step, I will present to you two new rules, and we will implement the two new rules in our drawing. According to rule number 10, if two circles are touching each other internally, here because of the fact that the small semicircle is located inside the small circle is located inside the big circle, it is defined that they have an internal launch at point N. That is to say they are touching each other internally at point N. And according to this rule number 10, the straight line that connects their centers together is OM. Why? Because point O is the center of the big circle, point M is the center of the small circle, and therefore OM is the straight line that connects their centers together. So this straight line OM, according to rule number 10, must pass through their touching point. Their touching point is here, point N. So if OM must pass through point N, it means that OMN is one straight line. OMN is one straight line. And what is the distance between their centers? The distance between their centers is of course OM. But what is the value of OM? The length of OM, from doing, it is very easy to see that OM equals to ON minus MN. Again, ON minus MN equals to OM. ON equals to capital R, it is the radius of the big circle. M it is the radius of the small circle, the small r. And therefore, in total, OM equals to capital R minus small r. So whenever you have an internal launch between two circles, that is to say the two circles are touching each other internally, exactly like in this drawing, then the straight line that connects their centers together, in this case it is OM, must pass through their touching point. In this case it's point N, or OMN is one straight line, and the difference and the distance between their centers OM is the difference between the radii. That is to say, it is capital R and small r. Okay? And we have also rule number 11. According to rule number 11, if two circles are touching each other externally, here because of the fact that none of those two circles are inside the other, we can say that the two circles are touching each other externally at point N. Okay, so there is an external touch between the two circles at point N, and therefore the straight line that connects the centers together is of course OM. Why? Because point O is the center of the big circle, point M is the center of the small circle, therefore OM is the straight line that connects their centers together. So this straight line OM must pass through point N, that is their touching point. Okay, so whenever you have an external notch between two circles, the straight line that connects their centers together must pass through their touching point. In this case, the straight line OM must pass through point N, or O and M is one straight line. O and M is one straight line. And what is the length of OM? For the moment, it's very easy to see that because of the fact that O and M is a straight line, it means that the length OM is equal to ON plus NM. ON is capital R, NM is small r, and therefore OM in total equals to capital R plus small r. So whenever you have an external notch between two circles, that is to say, whenever two circles are touching each other externally, like in this drawing, the two circles are touching each other at point N, then the straight line that connects their centers together, that is to say OM, must pass through their touching point, that is to say through point N, or on NM is one straight line, and the distance OM between the centers of the two circles will be equal to the addition of their radii with each other. That is to say, it is capital R plus small r. Okay? So we can actually implement the two new rules in our drawing. Because in our drawing we have this semicircle and this circle have an external notch between them at point H. That is to say, they are touching each other externally at point H. Therefore, according to rule number 11, the straight line that connects their centers together, that is to say, the straight line FB, must pass for their touching point, that is to say, for point H, or FHB is one straight line. FHB is one straight line, and the distance between their centers, that is to say the length of line segment FB, will be the addition of the two radii with each other. The radius, actually you can see it also from the domain itself. What is the length of FB? The length of FB is FH plus HB. FH is the radius of the small circle that is equal to small r. And BH is the radius of this semicircle that is equal to 70 units. Therefore, in total, the distance between their centers FB equals to small r plus 70. That is actually the addition of the two radii with each other. Why? Because the radius of this circle is small r and the radius of this circle is 70, and therefore the addition of the two radii with each other is 70 plus r. So if I know that FB equals to 70 plus r units, likewise, the smallest semicircle, this smallest semicircle, have an external launch with this circle as point G. That is to say they are touching each other externally at point G. And whenever you have an external launch between two circles, then the straight line that connects their centers together, that is to say FD, must pass through their touching point, that is to say for point G, or FGD is one straight line. So we write down that FGD is one straight line. And the distance FD between their centers will be equal to the addition of the two radii with each other. The radius of this circle is small r, and the radius of the smallest semicircle, it is equal to 35 units in its length. So GD equals to 35 units. Therefore, we found out that FD, because of the fact that FGD is one straight line, therefore FD equals to FG plus GD. FG is R, GD is 35. Therefore, in total, FD equals to 35 plus R units. So I write it down that FD equals to 35 plus R units. This semicircle have an external launch with the smallest semicircle, that is to say they are touching each other externally at point C. And according to rule number 11, whenever you have an external launch between two circles, then the straight line that connects their centers together, that is to say the straight line BD, must pass for their touching point, that is to say for point C. That is to say BCD is one straight line. BCD is one straight line. And what is the distance between their centers? The distance between their centers BD will be equal to the addition of the two radii with each other. The radius of this semicircle is equal to 35 plus 35, that is 70 units. The radius of the smallest semicircle is CD, that is 35 units. So the addition of the two radii with each other is 70 plus 35, that is 105 units. So we can write down that BD equals to 105 units. BD equals to 105 units. The small circle has an internal launch. First of all, the small circle is located inside the biggest semicircle, and it has an internal launch with the biggest semicircle at point I. That is to say, it touches the biggest semicircle at point I, this point. And whenever you have an internal launch between two circles, then the straight line that connects their centers together must pass for their touching point. That is to say, for point I. The center of the biggest semicircle is there at point O. The center of this circle is at point F. And the straight line that connects their centers together is OF. And this straight line OF must pass for their touching point, that is to say, for point I, or OFI is one straight line. I'll repeat again, that OFI is one straight line. And because of the fact that OFI is one straight line, we get that the distance between their centers OF equals to IO minus IF. Again, IO minus IF is the distance OF between their centers. And it is exactly according to rule number 10 that states that the distance between the centers of two circles or semicircles that have an internal length between them is the difference between their radii. The radius of the biggest semicircle equals to capital R, or I or IO equals to capital R. The radius of this circle equals to small r. So capital R, IO, that is capital R, minus IF, that is small r, IO minus IF equals to FO. Okay? You can write down that the distance between the centers of the biggest semicircle and this circle, that is actually FO, equals to IO minus IF. IO minus IF is the distance between the centers repeat again, the distance FO between the center of the biggest semicircle and the center of the circle equals to IO minus IF. FO equals to IO. IO is the radius of the biggest semicircle that is equal to capital R. So we substitute IO by capital R minus IF. IF is the radius of this circle that is equal to small r. IF equals to small r. So we substitute IF by small r. And finally we found out that FO equals to capital R minus small r. And the result is exactly according to rule number 10 that the distance between the centers of two circles or semicircles that have an internal length between them, the distance between the centers, it is equal to the difference between their radii. The radius of the biggest semicircle is capital R, the radius of this circle is small r, and the difference between their centers is capital R minus small r. Exactly like rule number 10. FO equals to capital R minus small r. Capital R equals to 105 units, according to what we have already found out, and small r is the radius that we are looking for, so we leave it as it is. So in conclusion, we found out that FO, the distance between the centers of the biggest semicircle and the circle, equals to 105 minus small r units. Okay. In the next step, I will present to you a new rule, and we will implement the new rule in triangle FBD. I'll repeat again, we will implement the new rule in the green triangle, triangle FBD. The new rule is draw in any triangle and it is called Stewart's Theorem. So the triangle that I will draw could be any triangle. This is triangle ABC. That could be any triangle. we know that the length of side AB is A, side AC equals to B units in its length, and finally side BC, this side, equals to C units in its length. In addition, we know that line segment AO equals to D units in its length. And we also know that the length of line segment BO is M, is equal to M units in its length, and line segment OC equals to N units in its length. Then, according to Stewart's theorem, the following equation is true: that A squared times N plus B squared times M equals to C with open brackets, and inside the brackets we have D squared plus M times N. I repeat again, according to Stewart's theorem, in any triangle, the following equation is true: that A squared times N plus B squared times M equals to C. We have brackets here, inside the brackets we have D squared plus M times N. Okay, we can actually implement the new rule Stewart's theorem in our main triangle FBD. So we copy triangle FBD in a new page and we will implement on it Stewart's theorem. We have already found out the sides of this triangle, so I will not repeat on it. This is triangle FBD that I copied from the original drawing. We have already found out that side FB equals to 70 plus R units in its length. Side FD equals to 35 plus R units in its length. And side BD equals to 105 units in its length. We also found out that FO, okay, we'll find out the length of FO. We found out actually that FO equals to 105 minus R units in its length. It is actually the distance between the centers of the biggest semicircle and this circle, that is 105 minus R units. Okay. I repeat again that we already found out that F0 equals to 105 plus R units in its length. What is the length of line segment BO? The length of line segment BO, from the drawing it is very easy to see that BO equals to 35 units. So I write it down in the drawing that BO equals to 35 units. And what is the length of line segment OD? The length of this line segment OD equals to OC plus CD. OC is 35 units and CD is 35 units. So OD equals in total to 35 plus 35, that is 70 units. OD equals to 70 units in its length. So in the next step we will implement Stewart's theorem in this triangle FBD. According to Stewart's theorem, FB squared times OD plus FD squared times OB equals to BD and we'll open brackets. Inside the brackets we have FO squared plus BO times OD. So this equation is the implementation of Stewart's theorem in our triangle FBD. According to Stewart's theorem in our triangle FBD, FB squared times OD plus FD squared times OB equals to BD. We open the brackets, and inside the brackets we have FO squared plus BO times OD. Okay. Here FB is 70 plus R, therefore FB squared is 70 plus R squared times OD. OD is 70, so we substitute OD by 70 plus FD squared. FD is 35 plus R, therefore FD squared is 35 plus R squared times OB. OB is 35, so we substitute OB by 35. And it is equal, on the other side of the equation we have BD. BD is 105, so we substitute BD by 105. And we open here brackets. Inside the brackets we have FO squared. FO squared is 105 minus R, therefore FO squared is 105 minus R squared plus BO times OD. BO is 35 and OD is 70. So in total BO times OD is 35 times 70. Here we'll close the brackets. In the next step we'll substitute 35 or any multiplication of 35 by x. So we'll define 35 as x. 35 equals to x according to our definition. And in this equation, we'll substitute 35 or any multiplication of 35 by a natural number, we'll substitute it by x. And we'll get that 70 is 2 times 35, therefore 35 is x, so Therefore 70 is 2x. So we have here 70 plus r squared is 2x plus r squared times 70. 70 is 2x. So substitute 70 by 2x. That's 2 times 35, that is 2x. Plus 35 plus r squared is x plus r squared times 35. 35 is x, so we substitute 35 by x. And it is equal to 105 is 3 times 35, therefore it is 3 times x, so we substitute 105 by 3x. And inside the brackets we have 105, that is 3x, minus r squared, plus 35 is x, and 70 is 2x. So in total, 35 times 70 is x times 2x. Okay, in the next step we will divide this equation by x. And we will get that here x will get cancelled, and also x will get cancelled, and here also x will get cancelled. So what is left from this equation after we cancelled x? We have here 2 times 2x plus r squared plus x plus r squared equals to, on the other side of the equation we have 3, we open the brackets here, inside the brackets we have 3x minus r squared plus x times 2x is 2x squared. We close the brackets. So here we will open the brackets. We have 2 times 2x plus r squared is 2x squared, that is 4x squared, plus r squared, plus 2 times 2xr is 4xr. Okay, in total this expression 2x plus r squared equals to 4x squared plus r squared plus 4xr. Plus x plus r squared is x squared plus r squared plus 2xr, and it is equal, on the other side of the equation we have 3 times, we will open the brackets here, 3x minus r squared, according to the algebraic identity that a minus b squared equals to a squared plus b squared minus 2 times ab, we get that 3x minus r squared equals to 3r squared, that is 9x squared, plus r squared minus 2 times 3xr is minus 6xr plus 2x squared. We close the brackets here. Here we will open the brackets and we get that 2 times 4x squared is 8x squared plus 2 times r squared is 2r squared. 2 times 4xr is 8xr. And we have here also plus x squared plus r squared plus 2xr. And the other side of the equation we have, it is equal to 3. Inside the brackets we have 9x squared plus 2x squared is 11x squared plus r squared minus 6xr. We close the brackets. In this side of the equation we have 8x squared plus x, 8x squared plus x squared is 9x squared. We have here 2r squared plus r squared is 3r squared. And we have 8x squared plus 2x squared is 10x squared. So in total, in this side of the equation, we have 10x squared plus 3r squared plus 10xr. And it is equal to, here we'll open the brackets, 3 times 11x squared is 33x squared, plus 3 times r squared is 3r squared, plus 3 times minus 6xr is minus 18xr. Okay, so we have here 3r squared on both sides of the equation, therefore 3r squared will get cancelled. What is left from this equation after we cancel 3r squared? In this side of the equation we have 9x squared plus 10xr, that is equal to 33x squared minus 18xr. Here we will add 18xr, we will subtract 9x squared from this equation, and we get that 9x squared minus 9x squared is 0, so in this side of the equation we left only with 10xr, that is equal to 33x squared minus 9x squared is 24x squared. Minus 18xr. We will add 18xr to this equation, and we will get that 10xr plus 18xr is 28xr, that is equal to 24x squared. 18x squared minus 18x squared is 0. So in conclusion, we found out that 28xr equals to 24x squared. Here we divide this equation by x, and we get that 28xr over x is 28r. That is equal to 24x squared over x is 24x. In the next step, we will substitute x by 35. And we will get that 28r equals to 24 times x, and x is 35. So we found out that 28r equals to 24 times 35. Here we will divide this equation by 7, and we'll get that 28 over 7 is 4. So in total, in this side of the equation we have 4r, that is equal to 24 times 35 over 7 is 5. So in total, in this side of the equation we have 24 times 5. Or 4r equals to 24 times 5. Here we will divide this equation by 4, and we will get that 4r over 4 is r, and 24 over 4 is 6. So in this side of the equation, in total we have 6 times 5. Okay, so r equals to 6 times 5. 6 times 5 is 30, so we found out that r equals to 30 units in its length. Okay, so we found out that the radius that we are looking for, that is to say small r, equals to 30 units in its length. That is the answer to the question. In the next step, I will summarize the lecture. In the drawing, we have a big semicircle. Inside this big semicircle, we have 2 smaller semicircles and 1 circle. It is given as the question that line segment AC equals to 140 units, and line segment CE equals to 70 units in its length, and our mission is to find out the radius of this circle. So first of all, we defined the relevant points for our question with letters, and we also defined the radius of the biggest semicircle as capital R and the radius of this small circle as small r. I'll repeat again. Capital R is the radius of the biggest semicircle and small r is the radius of the circle. Actually, it is given as the question that the length of this line segment AE, it is equal to 140 plus 70 units. So actually AE equals to 140 plus 70, that is 210. A equals to 210 units. But what is actually AE? What is the definition of line segment AE? AE is the diameter of the biggest semicircle. Okay? And we know that the diameter of the biggest semicircle equals to 210 units. Here, the diameter of the biggest semicircle is AE, and we know that it is equal to 210 units. But we also know that the diameter of any circle or semicircle is twice as long as the radius. And because of the fact that the radius of the biggest semicircle equals to capital R, it means that the diameter must be equal to 2 times capital R. So the diameter of the biggest semicircle equals to 2 times R, capital R. And from this long equation, 2 times capital R equals to the diameter equals to A equals to 210. We will derive that 2 times capital R equals to 210. We divided this equation by 2 and found out that capital R equals to 210 over 2, that is 105 units. So here, the radius of the biggest semicircle equals to 105 units. AO, that is the radius of the biggest semicircle, equals to 105 units, and OE, that is also the radius of the biggest semicircle, equals to 105 units. Okay? Then, it is given us the question that AC equals to 140 units. But what is AC? AC, it is the diameter of this semicircle. And because of the fact that the diameter of this semicircle equals to 140 units, it means that the radius must be equal to half of it. That is to say, the radius AEB equals to 140 over 2, that is 70, and the radius BC must be also equal to 70 units. Likewise, we know that CE equals to 70 units according to what is given as the question. But what is CE? CE is the diameter of the smallest semicircle, and therefore the radius must be equal to half of it. So the radius CD equals to 70 over 2, that is 35 units, and the radius DE must be also equal to 35 units. Then we found out the length of this line segment BO. From the drawing, it is very easy to see that OB, it is the same, OB equals to OA minus BA. Again, OB equals to OA minus BA. I'll repeat again. OB equals to OA minus BA. OA is the radius of the biggest semicircle, that is equal to 105 units. BA is the radius of this semicircle, that is equal to 70 units. Therefore, in conclusion, we found out that OB equals to 105 minus 70. 105 minus 70 is 35 units. In conclusion, we found out that the length of this line segment OBO is equal to 35 units. Then we found out the length of this line segment OC. From the drawing, it is very easy to see that OC equals to OE minus CE. Okay, here. OC equals to OE minus CE. Okay, so OE is 105 units, it is the radius of the biggest semicircle, and CE is 70 units. Therefore, in total, OC equals to 105 minus 70. 105 minus 70 is 35. We found out that the length of line segment OC equals to 35 units. OC equals to 35 units. In the next step, I presented to you two new rules, and we implemented the two new rules in our drawing. We have rule number 10. According to rule number 10, if two circles are touching each other internally, here, because of the fact that the small circle is located inside the big circle, it is defined that the small circle touches the big circle internally at point N. Okay? Then the straight line that connects their centers together, the center of the big circle is at point O, the center of the small circle is at point M, and the straight line that connects their centers together is of course OM. This straight line OM must pass through their touching point, that is to say from point N. Or OMN is one straight line. OMN is one straight line. And what is the difference between, what is the distance between the centers? The distance between the centers is OM. And that distance OM, from the moment is very easy to see that OM equals to NO, that is capital R, minus NM, that is small r. Or the distance between the centers of two circles or semicircles that have an internal between them will be equal to the difference between their radii. The radius of the big circle is capital R, the radius of the small circle is small r, and the difference between their radii, therefore it is capital R minus small r. So here D equals to capital R minus small r. Okay, then I presented to you rule number 11. According to rule number 11, if two circles are touching each other externally, here none of those two circles are inside the other, and therefore it is defined that those two circles are touching each other externally at point N. And the straight line that connects their centers together, point O is the center of the big circle, point M is the center of the small circle, and therefore the straight line that connects their centers together is OM. That straight line OM must pass through their touching point, that is to say from point M, from point N. Okay? That is to say O and M is one straight line. O and M is one straight line, and therefore the distance between their centers, OM, must be ON plus NM. ON is capital R, NM is small r, and therefore the distance OM is capital R plus small r. So whenever you have an external arch between two circles, that is to say whenever two circles are touching each other externally, like in this drawing, then the distance between their centers will be equal to the addition of the two radii with each other. In this case, it's capital R plus small r. Okay, then we actually implemented the two new rules in our drawing. We have this semicircle and this circle have an external arc between them at point edge. That is to say they are touching each other externally at point edge. And therefore, according to rule number 11, the straight line that connects their centers together, that is to say BF, must pass through their touching point, that is to say for point H, or BHF is one straight line. According to rule number 11, BHF is one straight line. And what is the distance BF between their centers? The distance equals to the addition of the two radii with each other. The radius of the small circle is small r, the radius of this semicircle is 70, and the addition of the two radii is 70 plus r units. So in conclusion, found out that FB or BF equals to 70 plus r units. If FB equals to 70 plus r units. So here, the smallest semicircle, this smallest semicircle, have an external arch with this circle. That is to say they are touching each other externally in this point, point G. And therefore, according to rule number 11, the straight line that connects their centers together, that is to say FD, must pass through their touching point. That is to say, for point G, or FGD is one straight line, and therefore the distance between their centers, FD, will be equal to FG plus GD. FG plus GD is, FG is smaller, GD is the radius of this semicircle, that is equal to 35 units, and therefore FD equals to 35 plus R units. Repeat again, FD equals to 35 plus R units. This is actually the addition of the two radii with each other. Why? Because of the fact that the radius of this circle is smaller and the radius of this circle is 35 units, and the addition of the two radii is 35 plus R units. So FD equals to 35 plus R units. Then the big, this semicircle have an external notch between with the smallest semicircle. That is to say, those two semicircles are touching each other externally at point C here. Okay, and whenever we have an external notch between two circles or semicircles, then the straight line that connects their centers together, that is to say BD, B is the center of this semicircle and D is the center of the smallest semicircle, therefore the straight line that connects their centers together is BD. This straight line must pass through their touching point, that is to say from point C, or BCD is one straight line. BCD is one straight line, and what is the distance between their centers BD? The distance between their centers, it is actually BC plus CD, or it is the addition of the two radii with each other. And the radius of the smallest semicircle CD is 35 units, the radius of this semicircle BC is 35 plus 35, that is 70 units, and therefore the addition of the two radii with each other is 70 plus 35, that is 105 units. In conclusion, found out that BD equals to 105 units. Here, BD equals to 105 units. In the next step, we know, we can see from the drawing that this small semicircle is located inside the biggest semicircle, and they are touching each other at point I. That is to say, they have an internal notch between them at point I. And according to rule number 10, whenever we have an internal notch between two circles or semicircles, then the straight line that connects their centers together, the center of the biggest semicircle is here at point O. The center of this circle is at point F, and the straight line that connects their centers together is OF. This straight line OF must pass through their touching point, that is to say, it must pass through point I, that is their touching point. Or OFI is one straight line. OFI is one straight line. And what is the distance between their centers? The distance between their centers is OF. And according to rule number 10, the distance between their centers must be equal to the difference between their radii. The radius of the biggest semicircle is capital R. The radius of this small circle is small r. And the difference between the radii is capital R minus small r. So here, F or FO equals to capital R minus small r. We have already found out that capital R equals to 105 units, and small r is the radius that we are looking for. So we leave it as it is. In conclusion, we found out that FO equals to 105 plus R units. This FO, the length of this line segment FO is 105 plus R units. In the next step, I presented to you a new rule, and we implemented the new rule in the green triangle FBD. The new rule is true in any triangle, and it is called Stewart's Theorem. So we have this triangle ABC, that could be any triangle. We know that the length of side AB is A units, side AC equals to B units in its length, and finally side BC equals to C units in its length. In addition, we know that line segment AO equals to D units in its length, line segment BO equals to n units, and finally line segment ON equals to n units in its length. Then, according to Stewart's theorem, the following equation is true. That a squared times n plus b squared times m equals to c, we open brackets, inside the brackets we have d squared plus m times n. Again, a squared times n plus b squared times m equals to c, we open the brackets, inside the brackets we have d squared plus m times n. We can actually implement the new rule in our triangle FBD. So this is triangle, so I copied the again triangle FBD in this new page. This is triangle FBD that I copied from the original drawing. And we already found out the lengths of each side of this triangle. We have already found out that FO equals to 105 minus R. What is the length of BO? From the drawing it is very easy to see that BO equals to 35 units. And here OD equals to 35 plus 35, this is 70. I repeat again, BO equals to 35 units and OD equals to 70 units. We implemented here Stewart's theorem. According to Stewart's theorem, we get that FB squared times OD plus FD squared times BO equals to BD. We open the brackets, inside the brackets we have FO squared plus BD times OD. I repeat again, FB squared times OD plus FD squared times OB equals to BD. We open brackets, inside the brackets we have FO squared plus BO times OD. So this equation is the implementation of Stewart's theorem in our grand triangle FBD, or this triangle FBD. FB equals to 70 plus R, therefore FB squared is 70 plus R squared times OD. OD is 70, so we substitute OD by 70 plus FD squared. FD is 35 plus R, therefore FD squared is 35 plus R squared times BO. BO is 35, so we substitute BO by 35. And it is equal, on the other side of the equation we have BD is 105, therefore we substitute BD by 105. Then we open brackets, inside the brackets we have FO squared. FO is 105 minus R, therefore FO squared is 105 minus R squared, plus BO is 35 and OD is 70. So in total BO times OD is 35 times 70. Then we substituted, we defined x, 35 as x, and we substituted in this equation 35 for any multiplication of 35 by a natural number by x. And we got that 70 is 2 times 35 and 35 is x. So 70 is 2 times x plus R squared. 70 is 2x, so we substitute 70 by 2x plus 35 plus R square is x plus R squared times x. X is 35, so we substitute 35 is x, so we substitute 35 by x. So in this side of the equation we have 2x plus R squared times 2x plus x plus R squared times x, and it is equal to, on the other side of the equation we have 105. 105 is 3 times 35. 3 times 35 is 3x. We open the brackets here. Inside the brackets we have 105, that is 3x minus R squared, plus 35 is x and 70 is 2x. And x times 2x is 2x squared. Okay, so here we divided this equation by x, so here x will get cancelled. And what is left from this equation after we cancelled x? What is left is actually, we have here 2 times 2x plus r squared plus x plus r squared equals to 3. We open brackets, inside the brackets we have 3x minus r squared plus 2x squared. Here we open the brackets, so 2 times, inside the brackets we have 2x plus r squared is 2x squared, that is 4x squared, plus r squared, plus 2 times 2xr is 4xr, plus x plus r squared is x squared plus r squared plus 2xr, and it is equal to, we have 3, inside the brackets we have 3x minus r, according to the algebraic identity that a minus b squared equals to a squared plus b squared minus 2 times ab, we get that 3x minus r squared equals to 3x squared, that is 9x squared, plus r squared minus 2 times 3xr is minus 6xr plus 2x squared. Then we open the brackets here, and we found out that 2 times 4x squared equals to 8x squared, 2 times r squared is 2r squared, and 2 times 4xr is 8xr. And we have here also x squared plus r squared plus 2xr. And it is equal to 3, inside the brackets we have 9x squared plus 2x squared is 11x squared, plus r squared minus 6xr. In this side of the equation we have 8x squared plus x squared is 9x squared. 2r squared plus r squared is 3r squared, and 8xr plus 2xr is 10xr. So in total, in this side of the equation we have 9x squared plus 3r squared plus 10xr, and it is equal to 3, we open the brackets here, 3 times 11x squared is 33x squared, plus 3 times r squared is 3r squared, and 3 times minus 6xr is minus 18xr. So in total, in this side of the equation we have 33x squared plus 3r squared minus 18xr. We have 3r squared on both sides of the equation, so 3r squared will get cancelled. What is left from this equation after we cancel 3r squared? In this side of the equation we have 9x squared plus 10xr. On the other side of the equation we have 33x squared minus 18xr. So in total, 9xr plus 9x squared plus 10xr equals to 33x squared minus 18xr. Here we subtracted 9x squared from this equation, and we found out that 9x squared minus 9x squared is 0, so in this side of the equation we left only with 10xr. In the other side of the equation we have 33x squared minus 9x squared is 24x squared, and we have also here minus 18xr. So in conclusion, we found out that 10xr equals to 24x squared minus 18xr. We added 18xr to this equation, and we found out that 10xr plus 18xr is 28xr. That is equal to 24x squared. 18xr minus 18xr is 0. So in this side of the equation, we left only with 24x squared, or 28xr equals to 24x squared. We divided this equation by x, and we got that 28xr over x is 28r, and 24x squared over x is 24x. So in conclusion, we found out that 28r equals to 24x. Here we substitute x by 35, and we got that 28r equals to 24 times x is 35. So in conclusion, we found out that 28r equals to 24 times 35. Here we divided this equation by 7, and we found out that 28 over 7 is 4. So in total, in this side of the equation we have 4r, that is equal to 24 times 35 over 7 is 5. So in total, in this side of the equation we have 24 times 5, or 4r equals to 24 times 5. We divided this equation by 4, and we found out that 4r over 4 is r. In this side of the equation we have 24 over 4 is 6, so in total in this side of the equation we have 6 times 5. So in conclusion, we found out that r equals to 6 times 5. 6 times 5 is 30. So we found out that the radius of this circle, the radius that we are looking for, r or small r, it is equal to 30 units in its length. Okay, thank you very much.